Engineers risked their lives to build the world's tallest bridge pillars, but connecting them became an enormous challenge. During the construction of the Millau Viaduct in France, they faced a major problem: placing the road sections on top of the towering pillars. Each section weighed as much as 25 locomotive engines, and there were 8 of them in total. However, no crane in the world could lift 5,000 tons to a height of 800 feet. If cranes were placed on the pillars, their immense height would cause them to collapse inward. The taller the pillar, the weaker its top becomes. This challenge turned into a nightmare for the construction team, delaying the project and costing the company $30,000 in daily fines. The Millau Viaduct, built in 2004 at a cost of €394 million, is the tallest bridge in the world, standing at an incredible height of 1,125 feet. It is even 45 feet taller than the Eiffel Tower. At such a height, it often appears to float in the clouds. However, the company that took on this ambitious project struggled with multiple obstacles, including frequent landslides and powerful winds reaching 130 kilometers per hour in the valleys of France. The bridge was necessary for the French government. In the 1980s, France faced severe traffic congestion, especially during holiday seasons when tourists traveled from France to Spain. The city of Millau, located in a deep valley, became a bottleneck. Vehicles had to navigate steep, zigzagging roads, leading to hours-long traffic jams. To solve this problem, France decided to build a direct motorway from Paris to Spain. However, the 1,500-foot-high mountains and the Tarn River made a straight route impossible. The only solution was to construct a bridge nearly as high as the mountains. At the time, such an idea seemed impossible. The tallest bridge then was the Golden Gate Bridge, standing only 250 feet above the water, 6 times lower than the Millau Viaduct. Experts doubted the feasibility of such a tall bridge, fearing structural failure. For years, the idea remained a dream. However, as traffic problems worsened, the government had no choice but to proceed. The engineering team faced 3 major challenges: erecting the world's tallest bridge pillars on mountain slopes, placing a 36,000-ton 4-lane highway on top, and installing massive steel pylons twice as heavy as an Airbus A380, all 1,000 feet above the ground. To achieve this, the world-renowned architect Lord Norman Foster was hired. His design had to be both delicate and strong, capable of withstanding enormous weight and powerful winds. However, Foster had previously faced a setback. His Millennium Footbridge in London swayed dangerously when people walked on it. If a similar flaw occurred in the Millau Viaduct, it could lead to disaster. After years of refinement, Foster presented a design featuring 7 pillars, with the tallest one reaching 245 meters. However, bringing this vision to life was another challenge. The team had only 4 years to complete the bridge, or they would face fines of $30,000 per day. Construction began in October 2001, but geologists warned of a new problem. The site's limestone was fractured, creating underground caves filled with unique bacteria used for making Roquefort cheese. These unstable conditions increased the risk of landslides. Despite the warnings, construction continued. Unfortunately, a landslide buried the foundation of the first pillar. Fortunately, no damage was done, and the team stabilized the slopes with cement before resuming work. To build the 7 massive pillars, 200,000 tons of reinforced concrete and 16,000 tons of steel bars were required. If all the steel rods were laid out in a line, they would stretch 4,000 kilometers, enough to connect Dubai to China. The shape of the pillars was also a challenge. They were thicker at the base and thinner at the top. Only 4-meter sections could be cast at a time, with heavy steel molds being adjusted repeatedly, causing significant delays. Precision was crucial. If a pillar's base was even 10 centimeters off, its top would be 6 meters out of alignment, making it impossible to place the road sections correctly. To ensure accuracy, GPS technology was used to pinpoint pillar locations and maintain alignment during construction. By November 2003, all 7 pillars had reached their final height. However, the most difficult task still remained: placing the 2.5-kilometer-long road sections at such an extreme height. The entire road weighed 36,000 tons, equivalent to 90 Airbus A380s. Even a small mistake could cost lives and millions of dollars. To minimize risks, engineers decided to build the road in steel sections. The only company capable of making such large steel sections was located 100 kilometers away. Each section weighed 90 tons and had to be transported carefully. More than 2,000 convoys were used to deliver them to the construction site. The plan was to slide the steel sections over the pillars like in conventional bridge construction, but the Millau Viaduct was far from ordinary. The pillars stood 250 meters high, with a 342-meter gap between them. Sliding such heavy sections across these gaps risked the entire structure collapsing. To counter this, engineers devised an innovative hydraulic ramp system that lifted and pushed the sections forward gradually. Additionally, temporary steel supports were placed between the pillars to share the load. This untested system had no room for failure. On February 26, 2003, the first test was conducted. If the hydraulic system failed, the bridge could collapse. Fortunately, the system worked, and in 2 days, only 200 meters of road was successfully placed. Engineers carefully monitored weather conditions, choosing calm days to continue construction, as strong winds could have destroyed the bridge. By 2004, road sections from both sides were nearly complete, leaving only the section above the river. This final connection had to be perfect. Any misalignment would ruin years of effort. The entire nation watched the moment live, with the French Prime Minister present at the site. Finally, the last hydraulic push connected the bridge with 99.9% accuracy. Next, 90-meter-high steel pylons, each weighing 700 tons, were installed for additional support. With the final road layers added, the total weight of the bridge reached 50,000 tons, the same as 1,200 battle tanks or a large cruise ship. To test its strength, engineers drove 28 trucks across it at the same time. Although the road was designed to sway up to 50 centimeters under heavy loads, it only moved 25 centimeters, proving its stability. On December 16, 2004, the Millau Viaduct opened to the public. The engineers had not only built the world's tallest bridge but also completed it ahead of schedule, setting a new record in construction history. We hope you enjoyed learning about this incredible engineering feat. Stay tuned for more amazing videos.